Doing today, all? Good, good. How did Scope Workshop go? It went. Why are we laughing? Not that great. Why? Which part? Zoom in and zoom out?
Yeah, I'm actually kind of still confused about when you create an argument.
Okay.
And then are we supposed to create an argument within the parameter?
Not sure what you mean, so let's tell me what you mean.
As a general practice, like if you were to write a function, my func takes in a number, you write the variable within the parameter next to my func.
Okay, so when you say parameter, where do you mean? We've got the definition up here, and then we have an invocation.
Up there, next to my func.
Okay.
My func, and then where you put the dummy variable on line 6.
Yes, so over here is where we basically define that, hey, we want to capture arguments based on the position that they give it to us. We want to capture whatever's in that position and store it in this variable. So this is going to be, we're saying here, let's make a variable called arg1. And this will have whatever value is the very first value they give us when they invoke the function down here. So this makes no assumptions at all. We can pass any type of data in here. So in this case, when I call the call that happens on line 11, arg1 variable will have the value 10. Yeah, exactly. What about this one over here? Do we have a variable for this one? We don't. Is anything bad going to happen? No, nothing's going to happen. We've just completely ignored that. We haven't set up a variable to capture the second position argument.
So the thing is, my question is, so when you have arg1 like in where it's at right now, right? But if you put arg1 is equal to 5 in line 7, so does
so if I have over here,
yeah. So in this case, actually no, that's a bad example. Can we do arg1 equals to well, actually, can we just do return arg1?
So just this?
Yeah, it will still return 10.
Yeah. So the last line of code that ran here is line 11, and so when I run this whole program, green is telling me the last line of code gave you line 10. It evaluated to the value 10.
Oh no, I'm sorry. I think what I meant is on line 7, if you put arg1 plus arg1.
Okay. I haven't run it yet. Do we have ideas what's going to happen here?
20.
Yeah, so basically every operation in JavaScript pretty much needs to come down to a single value. So on line 7, we're saying we want to return a value. And that value is going to be the result of whatever expression comes to the right. It doesn't matter how long this thing is. If I'm going to add 100 numbers or call 100 functions one after another, chained together, which I don't know if we've seen yet.
So arg1 automatically links up with the arg1 in line 6.
Yeah, so when we're defining this over here, this means, hey, start me out a variable called arg1, and its initial value should take whatever the first argument is down here. So let's clear this up semantically. This is sort of a recipe, right? And so my ingredients list, these are called parameters. So in the definition, we have parameters, and when we actually invoke a function, this is called the argument. So we're saying we're setting up a function to take in one parameter. And that parameter is going to have the value of whatever the very first argument is every time we call that function. So when we call my func on line 11, as soon as we enter inside of this code block, we'll have a variable on the local functional scope called arg1, and its value will be 10. Are you with me there?
Yeah.
Okay.
But we don't have arg1 on the global scope.
We do not have arg1 on the global scope. So we could double check that right here. And we get an error that there is no arg1 defined out there. Yes.
So, arg1 in line 6 is a parameter, and then 10 in line 11 is an argument, right?
Yeah.
So they're different.
Exactly. We're setting up a recipe. We're saying every time you call my func, give me a variable that's called arg1, and its value should be whatever the first argument was when it got called. So if I call this function twice, on the call for 11, arg1 will start out with the value 10. And on the call for line 12, arg1 will start out with the string value Chris. Does that make sense? Every time we run this function, it's a totally brand new scope where those parameters are initialized with whatever arguments got called for the currently running line.
So the latest one would be the one that's returned? Because if when they're hoisted, are they hoisted in order, the functions?
Okay, so the only thing that gets hoisted is like the actual definition, the recipe.
But not the function? When you call a function? Oh, the recipe. Okay, got it.
The recipe. It means like, hey, we can access the variable myfunc. So just to visualize that.
So it'll use the latest.
REPL, come on. So we see here that myfunc is a variable and its value is a function, which means that I can access that variable and then invoke it. So when I invoke it with the argument 100, I get back 200. And then we go to line 12 and we're going to invoke it with the string Chris, and it's going to smash those two together and give it back. So what's happening on line 7 is saying we need to return one value, and that one value is going to be whatever the result is of doing all this work that's highlighted over here. And so there's kind of an order of operations that goes on under the hood. It says before we can add anything together, we have to figure out what those variables currently are. So it's going to start on the left over here. It's going to say, do I have an arg1 on my scope? We do. It was the parameter, and it got initialized with the value 10. So it looks up on the functional scope, finds arg1, and it plugs in the value 10 right here. And it says, I'm still not done. Before we can call the plus, I need to know what the actual value is over here. And it'll look up on the scope, do the same exact thing, and say that's 10. And now the plus operator says, okay, I've got two actual values. I can do some work. And it will basically do this work and be like, okay, I got the value 20. I have a single value that I can return now. So when we invoke that, line 11 is going to output 20. That's kind of the steps that go on one by one, although this basically happens instantaneously. That's kind of how I think about what goes on under the hood. Yes.
So I think we talked about it the other class. So what happens when you take arg1 out of line 6?
Okay. So we take arg1 out of line 6. What variables are defined in my func?
arg1
No.
undefined argument value.
Okay, so let's take this one step at a time. The only way we see variables be defined is with what keywords? Let or const. Do we see any of that inside of my func? So my func is not defining any variables. So when we come inside of this function on line 7, it's going to say, find me a variable called arg1 and check my functional scope. We just said that in this functional scope, there are no variables. So it's automatically going to look to the global scope. And on the global scope of this program, do we have any variable definitions besides the function?
No.
We don't. So it doesn't find the variable anywhere in either of the scopes. And it's going to say, hey, I have no clue what you actually want me to do. It's not even going to plug in undefined because this is clearly a developer error where you're trying to access a value that's never, ever going to exist because we never define a variable there.
But what if you enter another line and you say enter and then you say let arg1 well, I don't know how you would declare a variable.
This is a variable declaration.
Oh, okay.
That's it. So in this case, I'm saying register a variable. Make me some space for something that's called arg1. But I didn't give it a value. So it will actually find this variable right now, but that variable's value will be what? Undefined. So it's actually going to plug in undefined for both of those. And when it tries to add two undefined values together, we get back NaN, which basically means, hey, I couldn't do a mathematical operation this isn't a number. Not a number is what NaN means. So if you see this, generally there's a bug. But the program did actually run because we accessed variables we declared. They just never got any value.
So when you put in, like, right now you have in the argument you have 10. So 10 is linked to arg1.
It's not.
Not
Okay.
The only way anything could be linked to these arguments down here is if I set up my recipe to take in an ingredient or to take in a parameter. And we're saying, hey, don't make me any variables for any of the arguments that they call this function with. So arg1 isn't assigned to 10. We've just defined a variable for no reason on line 7, and we never even gave it a value. Does that make a little sense?
Yeah.
Okay. Do we have any other questions from the scopes class? Did we get to the agent problem with bond? Do we see how tricky that is with the last two functions? Yeah, so when you got down to, I think, El Chifre and I forget the other one, you're just assuming, oh, bond was 007 on the global scope, so it must still be 007. But really, maybe it was like the Dr. No function. Some function above accessed the global scope and modified it before you got to that function. And that's really tricky to solve and pin down. So generally, we want to avoid mutating the global scope unless we have a reason to do so, which there are some valid reasons to do. Okay, how did arrays want? Yeah,
Sorry, another quick question.
no worries.
So you know how, like, when we define a variable, basically whatever we put into parentheses, that's we're creating a variable.
Yes.
When we create that variable, is that like the only way that we create a variable that allows it to be anything?
So by be anything, you mean be like any type of data?
Because you know sometimes in the workshop problems they're like this argument should take in a number. So but you know we usually just put num. Or like taking a string, we just put in like string. So we don't ever define what that argument is.
Yeah, so in JavaScript, we never define what type of data a variable could be. We just use them correctly. So let's make a better example here then. Let's say that we have a function that sums numbers. So this function is intended to take in two numbers and to add them together and return a number. And the documentation would say, hey, you should give me numbers here. Well, JavaScript is very loosely typed. So even though we intended to take numbers in here, JavaScript did its own thing and said, hey, I've got two strings, I'm going to smash them together and still add them in that sense. But nothing actually went wrong. So if we use functions incorrectly, wonky things can happen under the hood. And that goes back to the day 2 of class where we had types and coercion. Like we saw what happens if I call this with a string and a number. The function actually still works, but this might not be what we wanted to happen. And so this flexibility is really nice because it allows us to prototype things really fast and to make functions possibly work with many different types of data, but it can also bite you in the ass if you're not paying attention to what types of data you're passing where and what operations you're doing with them. So in this case, I might have accidentally plugged in the wrong value over here when I was going through my database. I might have plugged in a user's first name instead of their age or whatever, and the code still ran. And I might not notice this till on my front end, somewhere else I'm trying to show like, hey, what's like a user's age plus 10? And I get this weird output. Everything still worked, but it's not what I wanted to happen. And we would call that a silent error. So that's one reason that people will give JavaScript shit, because silent errors are really annoying and you're not going to catch them until you find wrong output later down the line, which means that we have to be a bit more observant while we write our code and pay attention to what we're plugging in where. And this will tie into my concept of actively debugging our code, catching these errors before they happen, which I'll touch on later in the class. So anyway, if we wanted to prevent this, if we wanted to protect the user from ever accidentally adding non-numbers together, what could I sort of do inside of this function? basically the pseudocode would be generally what we want to do here is we want to check that both A and B are numbers. And if they're not, we can throw an error and stop their program. So the very first time they do this incorrectly, the program will actually crash and they can correct it before they misuse this in a production environment. How can we check the type of a variable?
Type of, so if type of A is not equal, and the number, what we're just putting here.
Would you use the or operator or the and operator? Because you want both of them to be equal.
Yeah, so that's why I'm using or. If either of these fail, we'll throw an error.
You don't have to put two equal signs, or it's not.
So in general, when we're unsure, use the two equal signs. But in my case, I know that type of is always going to give me a string. And I'm comparing against a string, so there's no difference between the one equal sign and the two equal signs. Remember, the verbal explanation of two equal signs, or sorry, three equal signs is, are these things both the same exact data type and the same value? So 100 is the same data type and same value as the number 100. Now, two equal signs says, after we convert these things to a similar type, do they have the same value? And so what happens under the hood is there's a set of like 36 internal rules on how JavaScript manages the different data types. Programmers are lazy. We don't want to memorize 36 different rules. So instead, we're only going to use this when we know what the various outcomes could be. And in this case, it is okay for me to check a number against a string because I do know this rule. It's an important one, that when we have a number in a string, JavaScript says it's easier to just put quotes around the number to convert it to a string and now check if they're the same. So really under the hood, it would convert like this and say, okay, after I converted them to the same data type, they are the same value. And that's why 100 is loosely equal to the string 100. But if we go back here, is the number 100 the same data type and same value as the string 100? And it's not. So now we've basically added some code in here that if anybody calls some numbers with a string, the program stops and throws my custom error over here telling you, go read the documentation. You need to give me numbers. This is bad. And so here we could protect our code base from those accidental silent errors. So one thing that I'd want to point out here is that we have some redundancy over here where I had to type in this type of number multiple times. So maybe this would be a good place to instead isolate that functionality . So it's just an example of how you can begin to identify when you should make little small helper methods that do one thing and they do it very well. But we'll get to better examples of that. This is being very strict.
Does the case matter in number?
It does. It does. Because so not to bore you, but under the hood, each character in our alphabet is mapped to like a numeric value. And so when it compares strings, it kind of adds up all of those values and checks if they're the same. It's a very loose idea. But anyway, the capital N is not equal to lowercase n, which is why this would fail. And so I just know that type of returns capitalized explanations of the data types, which we could always check by Googling MDN type of, and we'd see all the outputs there. Yeah.
I have a question about converting. Is it possible to convert one type to another type?
Yes, there is. Does anybody know? We've got explicit coercion and we've got implicit coercion. What is explicit coercion? Yeah.
That's when the program, or when you change the value type rather than JavaScript is doing it automatically. So it's using number parentheses as a function, or Boolean or string that changes the value inside into either of those types.
Yeah, so you can imagine that under the hood. Anytime we come to documentation and we find a method, right, that exists for all data types, you're generally going to see this in the top left. So in here, the slice function comes from capital A array dot prototype. Don't worry about prototype, but it basically means that all things that are after this dot of prototype get passed down to all instances of this data type here. Does that kind of make sense? We don't have to worry about that too much. But this means if you see capital A array, it means the slice method will exist on all arrays. Anyway, when you see the capital letter there, the capital name of a data type, it refers, and we're going technical here, but it refers to like there's a global object inside of JavaScript that handles creating all arrays and creating all Booleans and creating all numbers. So that means that I can also go to this thing and say, hey, create me an array or create me a Boolean. And so how that works, explicit coercion, is I'm saying get me the Boolean value of the number 100. So basically, what are the falsy values in JavaScript? 0, null, undefined. What's a falsy string? Empty, nan, and I think we hit them all. That's pretty much it. That's the only thing we have to worry about when converting to Booleans. If it's not one of the values we just said, then it's truthy, and its Boolean value would be true. So 100 isn't 0, so when we convert it to a Boolean, we get true. So this is explicit coercion. I took this value and I got its truthiness. Implicit coercion is kind of when I let JavaScript perform some operation where internally it's going to do this and convert the type. So one shorthand way to implicitly coerce a Boolean value is the double exclamation marks. Because one exclamation mark basically says, hey, go get the truthiness of this thing and then flip it. 2 exclamation marks says, get the truthiness of 100, which is true, flip it to false, and then flip it again to true. So these basically do the same exact thing, but one I'm kind of letting JavaScript do under the hood. And implicit coercion also occurs when we have the 2 equal signs, or when we type something like this. What this is really saying is saying, hey, if the Boolean value of whatever I pass in here is truthy, run the code block. So we don't have to literally check if 100, we don't have to make this expression any bigger. We don't have to convert it to a Boolean ourselves. We can let the if implicitly coerce it and determine for us.
So you're saying that if it's true, then you lock out truthy?
It's saying if this thing is truthy, whatever this operation's value, whatever it resolves to, so in this case, whatever the result of this, which we know is going to be 110, whatever the result of that, if its truthiness is true, log this out. So you'll kind of see a lot of this, like at the start of our program, imagine that I have an input that says enter your name, or we'll just do it. So before the program advances, I want to get a name from you. No, it's not going to work for me because this is running on Java's their backend. So let's do it in Chrome Debugger. See up here, have you ever seen one of these boxes pop up? So basically all it does is that function takes in my string, my description that tells you what I want you to do. Whatever you type in here and then hit enter or you hit cancel is going to get stored in that variable that I wrote. Let name equal the result of prompting the user for give me your name. And so why I have this in the while loop is basically if they don't give me any characters, keep asking them. So if I come and I hit cancel here, it's going to keep popping up over and over again. So I didn't have to do any checks and say, hey, like if the name's length isn't greater than 0, because an empty string is going to be falsy. Now again, these are all kind of shortcuts. This window prompt method doesn't matter for our class. You'll learn that later on. It's actually pretty easy. But if it feels more comfortable for you to write the whole expression while the name's length isn't greater than 0, then do that. You have to write code that makes sense to you and eliminates as much like mental overhead as possible. And the shortcuts can come later. But if you understand what's going on here, then you can use those shortcuts to your advantage. Does this make sense so far? Okay.
Negative numbers are also tricky.
They are, which is really tricky at first. So, fuck. What does the index of function return if it doesn't find a character? -1. So let me just move this over here. So really when we use index of, we can't just return the value of it because -1 or an actual index is going to be truthy. But 0, which is an actual index, is actually falsy. So instead, how do I have to fix this if condition if I'm looking to do some code if z isn't in that string? So not +1. So the only way I know that z isn't in that string is if this function gave me back -1. But -1 itself isn't falsy. So I have to make a condition that will be false, that will be true when it's -1. So I had to check, get me the index of z. If it's not there, it's going to be -1. And if we have -1, then that means there was no z found. And so that's kind of a lot of headspace to think about when we're using the index of function. So index of is really good if we want to find a specific index. But if we're just checking if a string includes a value, there actually is a function called includes that's going to return true or false. And to me, that's a lot more readable and less to think about. You don't have to worry about that gotcha of the -1 and worry about the type coercion there. So that's just a trick that you learn to do what's easier for you. And in general, functions that return true or false values, they're going to read kind of like English, like is it a number? Does it include? And that's how you should write yours as well, to make it obvious. This thing should return a true or false. And in general, using functions that return true or false is going to make our life easier in those conditional expressions, which is what this is. Anything we plug in here to evaluate a truthiness is a conditional expression. It's just semantics.
So also another semantics that I see from a lot of readings. So basically, you know how originally you have name equals the empty string, and then if exclamation mark name it's truthy or falsy.
Yeah.
You know how in some books they would just say that if true then do this, or if false then do this. That's basically the same thing that you just did. Right?
What do you mean if I type this in here?
Yeah, because in some books they actually literally say if true, then do such and such.
Yeah, so I mean, I'll do this when I'm trying to demo an example of how conditions work for the class, but in real life, there's no reason for me to plug a hard-coded truth value, like true, in there because it's always going to run. So there's no difference then if I just got rid of this. Like we wouldn't wrap code in an always truthy expression just for the hell of it in real life. But while we have examples, we're just showing you basically if we plug a truthy value in, it will run. We good with that? How was arrays day 1? Good. Okay, so like we kind of, the first part of the course, the first 4 days, we kind of covered basic programming concepts that are in all programming languages, like scope, like operators, like calling functions, and adding pieces of data together. Now we're kind of moving into what are known as the complex data types, which are arrays and objects. And those complex data types allow us to do a lot more than what we could do with just those primitive values that only hold one piece of data at a time. Because if we can now write a function that can take in basically a list of numbers in an array, it doesn't matter if we only have 2 numbers or we have 1,000, that's always going to work. And that allows us to solve a lot harder problems. So complex data types sort of allow us to model real life problems that will work no matter how big the data set is. And so this is when we begin to start solving bigger problems that can actually be used in real life. So arrays are great, but the main reason that we use arrays is what property about arrays? Like how do we access elements in an array? Yeah, we use an index, and it's a numeric index. So really the main benefit of arrays is that we can access data in a certain order, which we haven't seen yet because we're just kind of modeling stuff with arrays. And tomorrow we'll move towards objects, which allow us to access data by name. So you can imagine that we'll, tomorrow, Monday, you get it. I know we haven't covered objects yet, but I kind of want you to see where we're headed. So you think about it while you're using arrays and don't use them as a crutch to always go there because you learned it first. But in general, we're using both an array and an object to model a real life entity, a person. And these people data concepts both have 2 pieces of data, one which represents a name and one which represents an age. So we'll cover objects on Monday, but we see that in here, we can sort of store the data by a property name, such as name and age. Whereas when we do it in an array, we access them by a number. And so this code over here, when our data actually means something, the string value represents a name, it's a lot easier to read and to code, hey, like to get the name, I go to person.name, than it is to use an array where really we're ordering data in here that doesn't really matter what the order is. We want to access it by what it actually means. So over here, we access a property on an object with this dot notation, which we'll learn next week. But this is a lot more readable, less to think about. Let me go to dot name to get a name. And over here, I had to literally look and be like, oh, name is the first index, or it's the 20th index. So that means that name is actually me0. And that's a lot harder and a cognitive load. So all our problems today are still going to be arrays, but they might not actually be they might not be representing that data in the best possible form. So I just want you to be aware of that once we introduce objects, we have a choice between how we store our data. And it depends on how we organize that data, depends on how we want to use it. If the order matters, then we want to use an array. But if the order doesn't matter, generally an object is a better choice. Okay, so just quick review. How do we access an element in an array? Even though I just showed you, how would we access this number 4 over here? Yeah, so first, what do I have to type? I have to access the whole array, right? So nums. Yeah, so now we're saying pull up nums, basically pull nums up into memory, and then let's go one level deeper. Let's pluck out a specific value inside of nums. And that's what that bracket notation means. And so we're saying we want to get the 4 here. How do I know how I can access that? Yeah, so arrays are 0 base, which means we have to go 0, 1, 2, 3. That's the value that I'm looking for. So this process here is kind of how the computer solves this expression. It says, well, first I'm going to go from left to right. First I need to see, do I have a variable called nums? I do. It finds this array. Then we say go one level deeper and pull out the third index. So it goes 0, 1, 2, 3, and gets me the value 4. So begin to think about like your expressions like one step at a time. And that's what REPL is really good to test out. Just little bits of expressions until you figure out what you're trying to solve. And then you can take this and plug it into your whole program. Okay, cool. So that's how we access elements. What about iteration? How can I access every element in this array? Okay. Cool. And what are the 3 pieces the for loop takes?
In assigning, doing I is 0,
long as I is less than num's length, increment by many length.
Yeah, and so we see here actually this dot length. That's exactly how the object works before that I showed you person.name. And that's because under the hood in JavaScript, everything is actually modeled as an object. So like nums is an array to us, but really it's an object. And we're accessing the length property. The same way that before I made a person and accessed the name property. That's an aside, this for loop is correct. So generally, if I wanted to log out every number in the array, what am I going to do? Yeah, that's correct. But generally, when we're setting up a for loop, we're going to do a lot more than just log out a certain element. And it's going to be really ugly and a lot of headspace to have this ugly nums bracket I over and over and over again through your code base. And it's very easy for you to make a mistake and mess that up at one spot. So as soon as we set up for loops, it doesn't matter what the problem is. The best practice is to actively debug, which means let's access the data that we want to access, store it in a variable that's going to be readable, and then let's log it out and make sure that's correct before we start to do anything else. So what I mean by that is let's go super readable and say, hey, we want to pull out the current number, and we do that by nums bracket I. And now we're going to log out that number and make sure that everything is good. Now we basically figured this out. We figured out how do I get each number. I made sure I have access to all of them. I never have to think about the fucking bracket again while we're inside this for loop. That's what actively debugging is. Let's figure out the code once, access the data we need. Once we have the data that we need in a readable form, it's a lot easier in our head to figure out the rest of the algorithm that we're going to do here. So, because now we can just read current num and we don't think about it. We've made sure current num will always be current num. And the other thing is that we want to generally put the label here so that we can double check what's being logged out here. Because if I did make this mistake, I catch it right now before I go any further. See, wait, at one point I thought my current number, I had it, but really I have an undefined value. And that's great for me to catch this right now before we start solving some of the problems that we're about to solve, such as this one. So just as an aside, REPL is basically a full text editor. There's a lot of shortcuts that you can do inside of REPL. One of them is that if we highlight a block of text, we can hold Alt and just move the arrow keys around to move that code block wherever we want. So I'll show you those as we go, but that's a useful one. So really, we were building up to, we wanted to sum all of the numbers in an array. So let's just move this. And so when we first start a problem, you write your function, you set up the data that you expect to take in, which is usually done for you in CodePen. But right now we want to stop and think about the entire problem. How do we sum up all of the numbers in an array, and sort of like in English? So first we start with what are we trying to return? We want to return a number, right? So I don't have to pseudocode this. Let's just immediately do it. We want to make some value that can store a number. And we have to think about what's the starting case. If they give me no numbers to return, what number do I mean, if they give me no numbers to sum, what number should I give back? 0. So if we're just going to set that up immediately. Put in the data that you're going to hold and return it, so we don't have to think about this. And now we can think about the problem. How would we do this as a human? Well, in English, we have to visit all of the numbers. And that means that we have to access each number, at least in code. And then we have to add number to our sum. That's generally the full problem that we need to solve here. And so now we can solve each of these steps one at a time and test it as we go. We've already just tested how to iterate over each of the numbers. And we made sure that we access each number. And because we have this label here, we know that we don't have to bother with trying to add numbers together and at the end figuring out why do we have like an undefined smashed in between a bunch of numbers. We can catch this right now. So we can fix that. And now we say, okay, we've got all of the numbers. We've got how to access them. So that leaves us with only one more step, and that's add number to our sum. How do we do that?
Sum plus equals current number.
And we run that, and we get 21 as the sum of all of these numbers. So just to show if we didn't log that stuff out, we'd end up with NaN. And now, because I didn't debug basically each step, it's a lot harder for me to hone in on exactly how we ended up with this NaN, and I might have to review every line of code. So it was better for us to make sure we accessed each number first before we started with the rest of our algorithm. So step 1 is always going to be make sure you can access the data you want to access, because it'll help us isolate bugs easier. Does that make sense? I know you're not going to want to do it at first. You're just going to want to hit the ground and run. But I promise you this is going to save you a lot of time in the long run and hone the muscle memory of the best way to write a solution. And not make us spend 20 minutes saying, what the hell is NaN? So, okay, so let's just, I missed a few things here as part of review. What are some methods we learned yesterday? How do we add to the end of an array? Push. How do we add to the start? Unshift. How do we remove from the end? Pop and remove from the start. Shift, great. Yeah, those are really useful ones for quickly adding to the front and the end of an array. So now we're on problem solving. Let's say that we wanted to instead get the max number of the array. So again, our problem solving steps. What is the, what do we want to return? Yeah, we want to return a number, right? So this means, well, we have to decide what number to return if we aren't given any numbers. So in general, maybe we could say like -infinity. But just to simplify this, let's just start out with -1000. So we've set up that we're going to start with this maximum number and we're going to return a maximum number. Ignore that we're assuming all of the numbers will at least be bigger than 1000, -1000, just to simplify this. What else changes? We still need to iterate over each number. We still need to access each number. But down here, what is our pseudocode? How do we know what to do when we have a number? Which number? Yeah, so I just left that in from before. We figured out the iteration. We figured out how to access. The last step that changed in our problem is basically the work that we do with that number. That's what I'm demoing here, is that overall the problem structure is mostly the same. We're going to set up an initial value. At the end, we're going to return it. We're going to iterate over a list. And the only thing that changed between these two problems is what do we do with the current number. In the last problem, we added it to a sum. But in this problem, we're saying that the English pseudocode is that we have to compare it. And if we're greater than the current max number, then we can update it. How do we do that?
Current num is greater than max num.
Yeah, exactly. We don't want to worry about the index again. We figured it out once. I don't want those brackets visually uglifying the code over and over because it makes it harder for our heads to read. So we have to translate that. We don't have to translate current num. It explains what it is. So we're done with that.
Then assign it to maximum.
So we reassign by saying max number is now equal to current number. Here, another shortcut to delete an entire line is command and delete. By the way, that's a useful one. And this function is not called sum numbers anymore. It should be called get max. So the last shortcut I have is when we highlight this word here, it also highlights or half highlights all other occurrences of the word. Do we see that? So while I have that highlighted, I can hit Command D, and now I have two cursors on both of the words. So real easy. Switch it to get max. Run this, and we see that the max number of this array is 6. And that works. Yes?
You still have the I less than equal to num stuff, right?
I do. Because undefined is not greater than whatever number was there, apparently. I don't actually know what it's doing to compare undefined against a number, and I shouldn't have to because I should never want to do that. It just happened to work out in my favor, but that's a silent bug that could stay in the code base, and it's because I removed the console log that I didn't even see it anymore. Yes?
Two things. For half the REPL tricks, are those also applicable in VS Code?
Yeah, so in general, they're the same in VS Code, at least starting out, but I don't think CodePen supports them.
Okay. And then for the max number, we could have also started with 0, right? Because I'm used to setting stuff to 0 like an empty.
Yeah, the point is that I wanted to be able to handle if we have negative numbers in the
Okay.
array.
Gotcha.
So more likely, I would probably set it to null and add a bunch of other checks. Like if it's null, automatically update it to the first number we get. But I wanted to keep it short, so we're just simplifying it to start with -1,000. That's not the best real world solution, but we're just practicing problem solving here. Yeah.
If you set it to null, then that would just be let max num and then semicolon.
So if I did let max num and a semicolon, what does it give me by default? Undefined. So yeah, there's a difference. Undefined is usually going to happen that the compiler gives it for you when you don't specify a value. Null will only ever happen by a developer setting something to null. Null is a placeholder, but it's represented by the developer to say, right now this has no value, but ultimately it should. So you'll only ever see null if you purposely put a null there.
So if I want to create this variable, then I would be like let max num equals null.
Yeah, if we wanted to make it null. And then later on, I would check, hey, if current num is greater than max num,
Then update.
or max num is specifically null, then it would have been time to update max num. So if we want to see how that would work, this is probably the best real world solution we could do here because it'll work with any numbers we get. Well, this is kind of a bad example because it just got bigger and bigger as we went, so it happened every time. But we see at the very first time, no matter what, our max num became 1.
Right.
And then because they were already in order, it happened every single time. So this is the best solution.
So null is null a number type?
No, null is, let's see.
Is it a boolean? Oh, it's a
Don't worry about that under the hood, that it's an object. But to developers, it means right now I have no value, but I expect at some point I should. So in the example of the forum before where I want to take a name from a user, I would start the name at null because it signifies, hey, I don't have it yet, but I want to later. Okay, cool. And then so the last example is just to iterate. We're going to have a bunch of these problems today with nested arrays. Whoa. Oh, it looks like I set up an argument in getMax. Am I using it? No. Where is nums coming from? Yeah, this is actually bad. I just had so much stuff here we didn't see the difference. But this is bad because actually if I call get max with 10, I expect to get 10 back, but I'm still getting 6 because my function is iterating over the global variable nums.
Put ARR.
Yeah. And so now this is why it's also great that we pulled that current number out because the rest of this logic in here is good. It doesn't need to be changed. I only need to change nums in 2 spots. That's another benefit to plucking the data out and storing it as a variable. Because if I do it wrong, there's very little code that needs to be updated. What just happened? Did this run?
Oh, yeah, so change.
Oh, is there, what is going on?
You have to change the ARR. Oh, you don't have
Wait, what? How are we still going over 1 through 6? Oh, do I call this twice somewhere? Oh, down here, sorry. Okay, that works. That code is correct up here. And in general, code does work how we type it. I just called it again incorrectly down there. Okay, so the last problem that we want to do real quick is getting into today's lecture where we have nested arrays. And so the idea here is we have an array of arrays that represent places, which in general doesn't make any sense because the order to these things don't matter at all. Instead, I'd much rather be able to access something like give me city and give me country. But instead, we have to deal with nested arrays to demonstrate that this sucks. So the only thing we need to change is access each place. And what we want to do is log out. So this is all gone. We don't need to actually return anything. What I'm looking to do is have this output on the console log.
Should placeable places
Yes, thank you. So this is also the danger of me copying and pasting code everywhere. And this would have corrected it. Okay, so think about this. In general, we have the same problem structure for dealing with arrays. We have some iteration over an entire array. We're plucking out some data, and then we're going to do something with the data. What is going on?
Shouldn't that be places in the line 84?
Let's
Oh, never mind.
let's make this clear. So we're just gonna reload REPL. Okay, cool. So we're iterating over the array, and our current value this time is another array. So my end result is that I want to log these things out. And this string relies on 2 pieces of data, right? I need to get 2 pieces of data. How can I get New York if my current place is this?
Use another one. No.
So use another for loop. Why?
Because you want to also loop through each of the elements in each array. So
Do I have to loop through them?
It's just trying to access like the first one and the second one. Wouldn't you just say places
Yeah.
I bracket 1 or
Yeah.
0?
In this case, I know that the data structure I'm taking in should be a place, and a place should have 2 pieces of data. A for loop isn't really going to help me because on my current spot, I don't know if I have a country or I have a city, and what am I going to do with it? It's going to be very hard to figure out what you're doing there. So instead, this is why I'm talking about look at what your data is and then figure out how to access it. So we figured out how to get one place out. Now we just got to go one level deeper. If I have this thing in memory, how do I get the city?
Zero.
Places.
So city is in the 0th spot and country is in the first spot, right? So what can we do? Any ideas on how to log this string out?
Isn't it just like 0, 0? So it's like the first array and then the first spot.
Yeah, so we could. So we could do this, and this will work.
What else can we do?
But this is ugly. This is ugly, especially thinking about going 2 levels deep. Is hard to look at, and there's a lot of spots that we could go wrong. This is still something that we want to be familiar with. So just to illustrate this, this is how we would this is how we kind of think through this and how this actually works if we want to do it in one go. So we've got places in memory, right? And we want to get a place, which means we have to plug one index into places and we'll get another array. So places 0 evaluates to this. And we can chain. We could say, okay, now that I've got this, I want to go one more level deeper. So how could I get the country here? Yeah. So this is how I sort of figure out like the whole equation that I'm trying to do. Go one step at a time and double check. This is the best way that you can learn is one step at a time rather than go all in one go, at least until you're comfortable with something like this. But still, this is really ugly. And if I have this in multiple places in my code, and later on we change where a city is or we add another property, you're going to have a lot of brackets to be updating. So instead, the best practice that you could do is save one step at a time in code. Pull out current place, so we never have to think about that first bracket again. We could just work with current place. And then we could say, let city equal what in current place? So not I, because I is really being used to help me get a place.
And then you can contact those two together.
Oh, okay.
Can we use just
Then
current
it would
place
just
and
be
use
one
our I
bracket.
to get this
What's that? So I wanted to finish the.
sorry. Can you just use current place and use I for iterate?
Okay, so if I used I and I put I in each of these, let's think about it. The first time this for loop runs, I is what? 0. So we plug 0 into places and we get back the New York, United States, right? I is still 0. We're still inside of here. So if I plugged I into both of these, what am I really plugging into that first array? What?
We'll get new.
I'll get New York for both the city and the country. So it's about thinking what data we're trying to access and why here. The for loop was used to access one of these arrays at a time, but it's not being used for me to access data inside of here. Here I know that all my places should have a city in the first spot and a country in the second spot. So it's okay for me to hard code that. There isn't anything wrong with hard coding how to access data when your data is in a predictable format like this. So that's totally okay. And so this is basically the replacement of if I said, go to my current places index and then go to 0. And then over here, go to my current places index and then go to 1. But it's a lot easier to just go one step at a time and save them into variables and make sure that works. Then do whatever work you need to do. So there's going to be a few problems like this today. And I can't emphasize enough. Figure out how to access your data, save it in variables, and then do the actual work that you need to do without needing to have this ugliness everywhere in the code base. Because when we scan our code, our head has to translate what this is, and it's tough. So the last thing that I will show you, there's a trick where this is really annoying to format a string like this and to plug in a variable and to hit space and then to plug in a string and then to hit space. So I've said that new JavaScript is a lot easier. And honestly, I never use for loops anymore, but we'll get to that. There's functions we can use that basically do this. Anyway, we have what's called template literals that you might have seen in some of the solutions so far. Basically, strings can also start with these backticks over here. It's just a string. But when we have these backticks, it's a special type of string. It's called a template literal. It means no matter what I type in here, it will like keep my formatting. So it's also a lot easier to format a big paragraph inside of backticks, which doesn't matter till you get to like displaying content. But the real benefit is that inside of backticks, we get the special ability to also evaluate variables. And why did that not work?
Got an extra dot.
Thank you. So over here, to me, this is easier to type and it's a little bit more readable once you get over being like, hey, what does that $ thing do? So it's just a little tidbit. You can start using this when you need to format strings. If you don't have the headspace for it now, it doesn't matter. You'll come back to it later. But you can still write strings like this if you want to.
Just to clarify, when you put the bad text, that basically means that you can do anything within inside, and it doesn't.
Yeah, so backticks, it's going to take whatever you type in there completely literally. So it will preserve white space. And then if we need to evaluate something, basically $, bracket sign, we can put any code we want in there. And whatever value it spits out will be stringified and just placed in that overall template.
That's the syntax, $, curly brace, curly brackets.
Yeah, so we can plug any code in there if we want. Like over here, we could say go evaluate 10 plus 100. 10 plus 100 becomes 110. 100 stringified just gets added on onto that string. It makes life easier, definitely. But we don't have to do this yet. I just like to show you tricks that you could slowly add. Okay, so then the last thing is why it was really great that we did something like this. It's because let's say your boss comes to you and they say, hey, we added something to our database. I don't have a good actual example, but thank you, zip code. Let's go with that one. I don't know what zip codes over here look like, so let's go with that one. And sure, there are numbers now too. So the data structure changed. And now our code is incorrect. We're not logging out the city and country, although we want to do the same thing. We're now logging out a city and a zip code. How can I change this? How can I fix this?
Go to country.
Just change the one.
Just add a variable.
Yeah, right? So one line of code, we now change everything. We didn't risk really breaking anything else or leading to a never-ending supply of bugs because we pulled our data out. We only have to think about this once. So if we get the right data and the right variables, the rest of the algorithm is fine. But if you had places 0i or whatever throughout here, there's multiple spots that you need to go clean up. That's really easy to make another mistake, push it up to production, and now have to go fix another bug that you just created. So I'm gonna push this really hard and you're gonna hate me, but don't be lazy. Do things in this way and it'll make life easier. It'll make your code more readable. It'll make you a better programmer. There's nothing wrong with multiple variables. There's nothing wrong with hard coding how to access data, but some reason beginners have an aversion to doing that and think that's not okay. It's totally okay. Cool, so I hope this helped a little bit with thinking about how to break down problems, how to actively debug them, and how to access data. And those are skills you want to use on every single problem. In general, CodePen is a pain in the ass to log things out. So sometimes it helps to just get started in REPL where you can test things or even test how to access nested arrays in this right side. Figure out the problems, how to access your data, then go back to CodePen. Cool? All right, today's slides will be quicker, I promise. Any final questions? Yes?
Let's say instead of like the second index, the United States was in like the 152nd spot in the array. How would you find out the index of an array that's in an array?
Okay, so one, that's a perfect example for why modeling data that's not based off order is a pain in the ass. Because as you're saying, yeah, we would have to actually print out the array and count out there. Or maybe loop over it and have it print out all of the indexes and the data, and then look at the output to figure it out. But that's a great example of why the array wouldn't be a good representation to model this. We could instead just gonna leave that. And over here we could have all sorts of other properties in the middle, and it doesn't matter how many of them there are because we can just go to the data we need by the property name, city and country. And so that's the correct way to model a place because our order doesn't matter here. So that's real life and the right way to think about how should I store my data. Good question. Cool. Okay, to the slides. Arrays 2. More methods and nested arrays, which we just looked a little bit at. So what method did we learn yesterday? That sounds really similar to this one. What is slice useful for?
Slicing.
Yeah, but what does it really do? Yeah, so it gives us a new array and it will copy all of the elements down. And so this is really important because we saw that with complex data types, we can modify the data inside of that array or inside of that object without reassigning the variable. And so there are some functions that are called, did we cover this yesterday? Some functions are mutable, which means they actually mutate the original data structure. And other functions are immutable. They'll give you back a new array that does some of the work that you wanted done, but the original is unchanged. So that's a little bit confusing, and that's because we'll have a lecture after we finish objects that's called pass by reference versus pass by value, and it covers the difference between mutating arrays and objects versus primitive data types. We can't really mutate primitive data types. We have to totally reassign a variable to a new calculated value. But with arrays and objects, we don't have to reassign them. We can do stuff that will actually change what's inside of them. Does that kind of make sense? Yeah, so this is what sucks about programming. Again, we're putting the cart before the horse because all these things are going to be at play, but that's a whole lecture that we have to go into next week. So just keep that at the back of your head and be aware, is my function going to mutate the data source or give me a new one? And did I want it to mutate the new one, I mean the original, or do I want something new? We have to think about that, but it'll make more sense next week. Anyway, keyword here when I'm reading the splice explanation is what? The very first thing that sticks out to me. Mutates, yes, exactly. That's what we're caring about. Splice mutates the original array. It's used to add or remove elements from the middle of an array. So all the methods we spoke about at the start of class, they add and remove from the start or the end, and that's great. But this is a specialized use case to actually mutate inside of an array. So the first argument is going to be an index. The second is going to be how many elements starting with that index do I want to completely delete? And it's going to return an array with all of the removed elements. So over here we've got this array of names and we're saying, hey, starting at the first index, which is John, I want to completely delete one element. So what do we expect will still be left inside of names? George and Thomas. And it says that mutable methods, they generally try to be helpful and return you something that's useful. If we just deleted some data, we might care about what we just deleted. So Splice will return us a new array with whatever we deleted. What do we expect to be inside of the returned array? Does that make sense? So in this case, we're saying start at index 1 and delete 2 elements. Who is getting kicked out of the Beatles? Yep. So names now only has Paul and Ringo, and George and John have been kicked out apparently across the universe. Cool, so the last bit about splice is that we can also add elements to that array starting at that start index. So in this case, we're saying, starting at the second index, I want you to delete one element. And in the same exact spot, I want you to put in this new thing. So we basically said, start at index 2, delete this thing, and put this thing right at index 2. Now, if I said I don't want to delete any elements at all, where do we think Ringo would go? Yes, that's and you. It's kind of I wouldn't expect you to know that, but yeah, that's correct. It means start at index 2. No matter what, the new index 2 is going to be this thing. Anything else would have been pushed to the right, no matter how many we deleted or didn't delete. But in this case, we did delete one. We got Pete back. So splice is kind of a complicated method. It actually seemed like you grasped that pretty quickly, so I don't think we'll go look at the documentation. But if it scares you, that's okay. We rarely use this one in real life because mutating arrays is generally bad. And there are better ways to build up a new array with what we want without destroying the original. And so here we have an example that if we didn't want to remove any elements, starting at index 2, delete nothing, and add these unlimited arguments inside. So splice takes unlimited arguments. We just separate them with commas. We can keep going and add 1,000 strings if we want. And going back to 2 days ago when I was here, how does a function access unlimited arguments? Yeah, but if we can't define parameters for unlimited arguments, right? Your hands would get tired trying to type out variable 1 through variable 1000. So JavaScript has a special keyword under the hood that it uses to access all of the arguments. I showed it a couple times. What is it?
Argument.
It's called arguments. And guess what? Arguments is an array. So console log doesn't define any parameters. It loops over an array of all of the arguments, and it puts each of them out to the screen. And now that we learned arrays, you kind of get how that would work. So anyway, I guess that makes sense then to show you the documentation. So see this here? See the ... This in the documentation is basically telling you that it can take unlimited arguments all the way through the end of the function. And what did the brackets mean?
Arrays.
No.
Optional.
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 Yeah, so this isn't actual code. It's a visualization of what the parameters do. And so the brackets mean optional. And the ... or this style over here, item 1, item 2, ... means unlimited arguments. So now you've seen all of the different visuals that we put inside of documentation. So when you see this, try to understand what it's doing, but always read the parameters as well. Because in general, it will also tell you special edge cases, like what happens if you don't pass in anything for this optional argument. It'll take some default value. Okay, going back. So we threw Pete and Stuart into the middle of that, starting at index 2. We removed 0 elements, so what splice gave us back is an array with no elements because nothing was removed. Cool? Join method. So join basically concatenates all of the elements of an array into a string without changing the original array. And so by default, if we pass no value to join, it's going to use a comma. So it's basically going to say, hey, grab this thing, make it a string, add a comma to it, smash the next one on, add a comma, smash it, add a comma, smash it. And there's no comma at the end. It only puts these delimiters, they're called, in between all of the elements. And so today's workshop is going to have you implement the join function without using join. So let's think about problem solving. If we want to do join, what type of data are we returning? We're returning a string, so right away we'll create a string. What's a good default value for a string? Empty string, right? And at the end, we're going to return the string. Now, how are we going to access all of our data? What do we need to do? We're going to need a for loop. We're going to pull out the current value, and we're going to add the current value onto that string, right? And now, what do we also have to add? We're taking in one argument called the delimiter. So we just threw the current value onto the string. What else do we have to do? So we grabbed Paul. We threw Paul onto the string. Before we go to the next element, what do? We add the delimiter to the string, right? But there's a catch. When we're on Ringo, we don't want to add the delimiter. So when do we want to add the delimiter?
After the element.
After the element, but on the last element, we don't, right? There's no delimiter because this was the last element. So what do we got to check? We need to, in English, we need to make sure we're not the last element. So if I is less than the length minus 1, right? Because the final index is going to be the length minus 1. So that's kind of the problem-solving approach of how you'd implement that. And generally, when we're learning these functions, try to think about how it actually works under the hood. It will make you understand it better. And a lot of them aren't that complex. They're pretty basic functions that the programmers didn't have to include in the library, and we could write them ourselves. It'd be annoying, but join isn't too hard. So hopefully the problem-solving approach helps you, and then it helps you understand join a lot more because you kind of saw inside of how it works. Moving on. So in this case, we actually passed our own delimiter. We said give us a space, the word and another space in between all of the elements of the array. So we get Paul and George and John and Ringo. And we don't have a space and space at the end, right? Because we would have checked if we're at the last element. Any questions on how join works? Cool. So concat method merges 2 or more arrays into one. What's an important takeaway on this description here? Yeah, it gives us a brand new array. It doesn't actually mutate the existing one. So we have these 2 arrays, one with Ringo, John, one with Paul and George. And basically, we call concat on the array that we want to basically have its values come first. So we're saying, hey, take the elements that are in older. So I want an array that has Ringo and John. And then I want to take whatever's in the other one and basically smash it onto the end. But give me that as a new array. So our output is a new array with Ringo, John, Paul, George. And we see that the original array wasn't changed. Does that make sense? What do you think the implementation looks like for this one, which I think you also write today? What are we returning? Yeah, so how are we going to set up our initial thing? Empty array, great. And then we need to iterate data again, right? So another for loop that we're going to get very comfortable with. And every time we're in the for loop, we're going to, in this case, we have to have 2 for loops. One that goes over array 1 and one that goes over the second array. Right? And in each of those, we can pull out the current value. And where do we put it? Yeah, we put it into the array we're going to return. So you could write 2 completely separate for loops, or you can write one for loop that loops over an array, grabs the current value, and pushes it out, and then loop that for loop in another one that will change which array you're iterating over. That might not make too much sense, especially when we're only going to have 2 arrays, but it would allow you to set up your function to work with unlimited arrays, or the arguments. Don't worry about it. You can write 2 separate for loops. That's fine. Nested arrays. So right off the bat, if I wanted to pull out the one value Chicago, what do I have to do here? In one line, what's the first thing I need to access? I need to access related things. And then within related things, what's the next thing I need to access? Yeah, I need to select this array, right? This entire array over here. And we just said that's the first numeric index. So now I've got related things, bracket 1. And so now if I figured out how to grab this array, how do I go one more level deeper to get Chicago? Yeah, so we'd have related things, bracket 1, and that's how you kind of think about it, one step at a time. So related thing 0 gives us the array with Windows and Mac OS. Related things 1 gives us New York and Chicago array, and the 0 will get us New York. Thank you. The length of related things is what? 2, yeah, we only have 2 top level things in that big array. There's only 1 comma that's out at the top level. Sometimes that's a little confusing. People think there are 4 things in here. But no, the top level array is an array that holds 2 more arrays. And this is a perfect example that while these things are related, actually, they don't have anything in common that we could store as an object anyway. So this would actually be okay to represent. Not too useful, but it does kind of make sense. We have groups of things. All right, looping. We want to loop over this, and we only want to log out strings. What problem do we have? So we're creating a for loop. We're going to look at the current value. If we just logged out the current value, what problem do we have? Yeah, we have different types. So if we just logged out the current, sometimes that would be an array, sometimes it would be a string, but we don't want to log out arrays. So what's the only way to check if something is an array? Why type of? So what is the type of an array? So is that enough to know if we actually have an array? No, because we could also have an object, or we could also have null. Yeah, full circle. So the only way to know for sure that we have an array, array dot is array. And so we see there, capital A array, right? Dot is array. That's that global array object popping up again. So if we went to the documentation, we would see capital A array dot is array. That means that function lives on the global array. But we saw like with dot prototype dot splice, it meant, hey, these functions will get passed down to instances of arrays. So that's the difference between prototype and when it's directly on the God object, so to speak. But that doesn't matter. It's for your own knowledge. You'll get there. So we've got our main for loop. We're pulling out an element, but we said we have a problem. We have to check if we have an array or if we have or if we have a string. If we have an array, what do we actually have to do? Yeah, we have to iterate through it. It's the only way that we can get to those strings. So this is general convention when we have nested for loops. If you're using the one-letter indexes, we'll go I, J, K, L, etc. So again, best practice. Let's pull out the thing that we're accessing now on the current element. We don't have to have over here let name equal RSVP groups I and then bracket J because that's ugly and hard to read. So one step at a time, let's just pull out data only once. So we can pull out a name, we can log out a name, close the for loop, close the array path. Else, we're on the string path now. We could just log out the element, close that, close the for loop, and this will get only strings. Questions here?
The else part, right? So that's if I'm a little confused on the else part. So the first is that if it's an array, do that.
If it's an array, do this whole for loop.
Right.
Else it wasn't an array, which means we're safe to log out the string. Yeah, we're assuming that for this problem you only have an array of arrays or strings.
Okay, right.
Cool. So most often nested arrays are used to represent a grid. And the inner arrays represent rows of the grid, and each index of a row represents a column. So one difference from math is where is my 0, 0, or my origin of the grid?
On the bottom left.
So, okay, think about it for a sec. If we plug top left, if we plug 0 into grid, which of these rows do I pull out?
The first.
We pull out this one, right? If I plug 0 into that, that means that this is my 0, 0, right? So it's a little bit of a head inversion when we're dealing with grids, that they're kind of going to work opposite to math. But so if we went to every row of this grid and we plugged in the same index, so like we iterate over, we pull out a row, and for each row we pretty much go to index 2, that's how we get a column. So if I did that for each of these rows and I went to index 2, I'd log out all the 3's, and that's a column. Does that make sense? Whereas if I want to get a row, I just plug one value into grid. And because I get back an array, that represents a row. Does that make sense? We're pretty high level today.
So if you say 0, it's gonna spit out just 1, or is it gonna spit out 1, 2, 3, right? 1, 2, 3.
Yeah, so if I say just 0, I'm saying go to grid, get me one element that's at the 0th position. Which element, what's the first element of grid? It's an array, right? So that whole array is what gets spit back to me.
And then if you put another,
Yeah, because we just said that 1, 0 gets me that whole array. Well, on that whole array, if I plug in another index, now I would actually get a number, finally, that represents a cell of the grid. So anyway, here's how we would access the first column, which are all number 1s. It says, hey, we have to go to every single row. So to do that, we increment the first thing that we plug in here, basically, is what changes what row we're on. So kind of, what is this? Is this our y or x? So it confuses me too. Yeah, it's our y. So if we increment the y's and we get different rows. Now we plug in the x, which determines how left or right we go. And if we just stay at 0, the furthest left, we get the whole first vertical column, which is all 1s. Does that make sense? Cool. So,
I have a question about the grids.
yeah.
Because it's just like the way you typed it out, it becomes a grid. Does that become visually useful? Is it used in real life?
Definitely. So remember, code is read a lot more often. Sorry. We write code mostly for humans because actually, under the hood, JavaScript deletes all white space and turns it into one never-ending line anyway. JavaScript doesn't care what it looks like. All that formatting is for us. So if we're representing something as a grid, one, we name it grid to make that obvious to the reader, but two, to make it easier to visualize, we should space it out like a grid because this will make it a lot easier just for you to think about as well. So this is completely done visually. It doesn't affect the code at all. If I smash this all into one line, there's no difference. So formatting didn't change anything, but it helps us. It's just visual cues. And the more visual cues we give, the less needs to be translated, which allows you to think harder and with less stress. And so this might be a little bit easier if we wanted to do this within the 2 for loops. We have one for loop where on each iteration we can grab a row. Then we have another for loop, and inside of there, we might not even need another for loop, yeah, if we're only doing one row. So yeah, but we can pull out the row, and then we can just access one index of the row and not have to have the double brackets, which makes it a little bit easier. All right, what was your favorite method today?
I like the $sign.
Template strings? Yeah, template strings are great. Yeah, just a bunch more methods. I mean, join is pretty useful when we need to format strings. So important one addendum is the opposite of join is split. How much time have I taken up? Okay, so couple quick examples then. So this is a date string. This is what my SQL database, this is how it formats strings, and it's super annoying. Because if I want the month, the date, and the year, I now have to code to get it. So the opposite of join is split. And it's a function that we can call on a string. And what do you think we can pass to that function? a delimiter, and what do you think we can get back? I'm leaving you super open-ended here. We can get back an array, and so if I said split this on what do I probably want to split on? Dash. So what do we think we'll get back?
99K, 01,
So now I could type this out and say let year, oops, I didn't save that thing. So let's say year equals what? Yeah, so we've got the year now. So I could continue, I could get the month and the day. So I'm going to show you one last ES6 tidbit. You can use it if you want, but don't let this complicate you, but it's super cool. So if I'm expecting to get back an array, and I immediately want to name some things inside of an array, we have something that's called array destructuring. And this is going to look super weird, but basically, this means that I'm expecting to get back an array, but I actually want to name variables inside of that array and pluck them off. So one line of code to do that. So visually what this is saying is, hey, I expect to get an array back on the right side. Take the thing that's in the 0th spot and give me a variable called year. And take the thing at the first spot and put in a variable called month, and the same thing for day. This might look really ugly and your head is spinning. Don't worry about it, but if you save the trick, you can use it. And if not, when you get better with arrays in the future, you'll be able to know this exists and come back to it. And it'll clean up your code a bit rather than having let year equal whatever 0 or month or whatever. And so I could have also used this up here. Any idea what I could have done? So places I is an array, right? And so I wanted city from the first spot. And let me just turn that back on. And so that cleans that up even more. And my debug that we needed to fix earlier would have been even quicker. This isn't to discourage you. This is to show you that code actually gets easier the more that we write it. And it's going to get shorter and shorter and actually more readable. But right now, that's a lot of different tricks to take in, so we don't have to worry about it. I'll link to it. It's called array destructuring. And we could do the same thing with objects, but I'll show you that next week. No, that's the difference.
So it's more like you just want this to be
If we want to pluck things out of an array and we don't care about date pieces, which I don't, then this is great.
What is it called again?
Array destructuring. Yeah.
Question. So your console log, instead of putting year one date, if you put month date year, it will. No, console log.
Oh,
Month date year. So you give the.
this is what you want?
Yeah.
Yeah, I don't have an array. Month, day, and year are specifically the values that came out of date pieces,
That's what I was
which so this is how you could do both. To get date pieces, we save it into an array, and then we pluck off of date pieces, and now I have a variable for all of those. That's how it works. Cool? Yeah.
So I was reading about the for each method.
Yes.
with arrays. Is that, can you explain that, or is it better to stick with for loops instead of doing?
Okay, I will show it too because I love it, but we're going to cover it later in the course because it involves passing functions into functions, which is a little bit complex of an idea. So you can imagine that in programming, there are 3 sorts of paradigms. The first one is called imperative programming, which means we're going to write out every little instruction that we want the computer to do, like a recipe. And so that's mostly the style that we've been using, where we're literally writing out for loops to spell, I want you to start from here and to go to here and do all of these little things. That's imperative programming. It's probably a more common style among newer people or people who never want to grow. Then there are two other styles, or one is object-oriented programming, which we're not going to talk about at all. And then my personal favorite is functional programming. And so functional programming is like, let's isolate our code to really small problems that are all little functions. And now our main algorithm is just calling functions with other functions and composing them and piping the result from one function to another. And all of that sounds crazy, but it makes your code super dynamic, super composable, and super maintainable. So one example of that earlier was doing something like this. Let's find a really small little function, and then we can build bigger from here. So I'll show you a lot more ways to use functional programming as we go that actually make sense, that show the power of it. But just to show you where we're headed then with for each is, I already named something nums. So for each is a function that we pass another function into. And basically what it means is we tell it, hey, go to every single element in this array and call my function with the current element. So I'm going to do another ES6 thing here. For each also came from ES6, but here I'm going to write an arrow function, which is just a short little function. So basically it's a shorthand syntax where we can drop the function keyword, we can use an arrow. And if I'm only taking in one argument, I can omit the parentheses. Again, don't let this overwhelm you. It's just to show you it's going to get easier. We could just in here say, hey, so we've got these numbers 2, 4, 6, and we said, hey, for each number, give me a function that will give me the current number. I don't have to worry about the for loop. I don't have to worry about when this for loop ends. And I don't even have to do the thing where I plug in the index and get the current number. Say, for every number, I want you to give me the number, and then I'm going to log it out. So the implementation is that they have a for loop where they pluck out the current value, and they call my function with each current value. So my function runs, and then it goes to the next value, and then my function takes in the fourth, and I log it out. Does that kind of make sense, even though we don't feel comfortable writing it? The general idea of why this is way easier than if I write the for loop out myself.
But where did num come from? How does it know?
Okay. I hate switching between different keyboards all day. This is the implementation of for each. So we said we can pass any values into functions, and this will make more sense once we cover pass by reference, pass by value. But I'm going to call for each.
So it replaces
Here.
argument.
Do we see the difference right here? I'm not invoking console log. We saw that I can just go over here and say, what is console.log? It's a function. So I can pass this function without invoking it. I can pass it to the for each function that I just wrote. So array is going to be this array of 2, 4, 6. And callback is going to be a reference to the console log function, which again, we'll cover that next week. But basically that means if callback is a function, I can invoke it inside of here. So the for each implementation is a loop, gets the current value, calls the function with the current value. And so when I run this, my implementation has the same exact output as what we just did. So that's where current comes from. They give me current, and it gets plugged into this function I defined down here. Right? Okay. So there's another one. For each is the stupidest one there is because it doesn't really do anything. It just calls a function back. But if we wanted to transform an array, basically what this one says is take each number in an array, run it through this little function. And so in here, arrow function, I can omit the return. Basically, this is saying, take one number and spit back that number times 3. What map is going to do is it's going to give me a new array that has all of the values it runs them through that function, and we're going to get back a new array that says, hey, what was the result of running each of these things through your function? So 2 times 3 is 6, 4 times 3 is 12, 6 times 3 is 18. So now if we run this, tripled nums is an array of those numbers tripled. Even numbers is still how it is. So let me just change this for 1 sec. And so where functional programming gets crazy is, let's say I wanted to map all of the numbers, I want to triple them, and now I want to know which numbers are even. And I want back only the even numbers. There's one more, or there's a lot more, but this is the last I'll show you. That's called filter. And it says, my function here will take in a current value, and it's going to return true or false. Give me only the values that came out truthy. So what we're going to do is say we're going to take in a number, and we want to return whether number mod 2 is equal to 0, which means if it's even number or not. And what I fuck up. So 1, 2, 7 got mapped, and it became 3, 6, 21. And then we filtered 3, 6, 21 to only the numbers who are even. And so that comes back to be just 6. But really, these functions here are really small helper functions, which means we could have just done and this is what functional programming style is. Let's write really small functions that allow us to do kind of a lot of work with a lot less code, and the code even becomes more readable. Obviously, this is overwhelming for where we're at right now, but it shows you that the more you put into this when we first introduce it and want to improve your style, you can write a lot shorter code that's a lot more maintainable now. And it's a lot easier if our boss comes and says, hey, we didn't want to triple numbers, we want to quadruple them. I can just go change this right here. And maybe I want to change the name too. But the point is that it's not going to bug out. There's only one spot that I have to worry about that happening. Okay, so that's a great question. Don't be overwhelmed, we'll get there. This weekend we open up our first optional project, which is basically your chance to work on a much larger problem and sort of work by yourself. 100% optional, doesn't matter if you do it or don't. It's good practice to build a larger program. I'll open up the workshop right after class. You'll see it as a workshop. There'll be instructions there. So try to write tidy code. Try to think about the various little steps you need to do rather than tackle it all in one go. And then you can basically put that in a REPL and email it, not email it, just Slack the link to Noel or myself, and we'll give you a detailed feedback ASAP. And so what this problem is going to be is you're going to get a big grid, which is an array of 9 arrays. And each of those arrays is going to represent a row of a Sudoku board. So Sudoku board, we kind of see it back here, but it will be filled in with numbers. Your job is to return if the board is valid or not. And so that sounds crazy at first, and your first go might be to write a bunch of crazy for loops and just brackets and for loops everywhere. But if we really break it down to one little piece at a time, it can get a lot easier to manage. Just write one function and check it. And then we're going to build up a main loop of the functions a lot easier. So I'll elaborate. My functional programming solution for this is like 2 lines of code, by the way, but don't worry about that. We'll talk about it. I'll show you how. But for yours, let's think about what's at the real meat of this problem. We need to determine if a set of numbers is valid. Basically, a Sudoku board is valid if each row, which is a set of 9 numbers, has all of the numbers 1 through 9, nothing else, and no duplicates. So if each of the rows are valid and each of the columns are valid, and lastly, the hardest part is each little subgrid. I don't know if you have a visual of a Sudoku board in your head, but you know it's broken up that like the top 3, the 3 right below that, and the 3 right below that are like the top left quadrant. Well, those 3 also have to only be numbers 1 through 9 with no duplicates. So at its core, we have one function called isValid, and it should expect to take in 9 numbers. It doesn't care if the thing is a row or a column or a subgrid. So let's start with that. Let's write a function that, given an array of 9 numbers, is it a valid set of 9 numbers? So now for the rest of the problem, we need to find a way to get each row and to get each column and to get each subgrid. So hold off on subgrid, that's the hardest part. See if you can get a row. So if we have a nested grid, how do we get a row? We just access one element, right? So really, all of the rows in the grid is just the grid itself. It's a list of all the rows. So get row, get rows is what we should do. But that one's easy. Get column, however, is basically going to be one for loop where we have to go through each of the rows and then go to whatever index they passed in. So if I say I want to get the first column, or let's say second column, you're going to for loop over all of the rows, and to access the element of that row at that column, you plug in the index. Then spit back an array that has all of the elements that were in that column. And so that's my get column function. So what we want is we want all the columns. So we make another function called get columns. And that one can loop through numbers 0 through 8, which are all our all our column indexes, and it can just call get column. And then you could smash all those into one big array. So if we have get rows and we have get columns, we can concatenate them, and now we have a big list of all the 9 numbers from a row and all the 9 numbers from columns. You're still with me? I know it's very fast and high level, but this is how we break down the problem without 24 loops stepping on each other. So forget about the subgrid. See if you can get rows, get columns, and then return whether all of those are valid by running each of those through your set of your valid function. So see if you can get those little pieces, and then we could talk more about how the subgrid works, but try to give that one a thought anyway. So just try whatever little pieces you can. The README will talk a little bit more about what I just said. But if you write a bunch of functions, you're getting closer to breaking problems down in that functional style. All right, any final questions?
I have one.
Yes.
It's a little bit more basic, but
No such thing.
in loops, why is there an else if and an else?
In loops, why is there?
Like sometimes you say else if, and then sometimes you just say else. Why would you use one over the other?
Yeah, so in most of the examples that I did today, it was simple an if or an else, but pretend we want to do so this would be like sort of a problem that it wants us to only do one thing for each number. If the number is divisible by 3, log out fizz. If the number is divisible by 2, log out buzz. And if it's not divisible by either, log out nothing. So this would call for an if, else structure. So we use an else if we want to catch anything that didn't pass any earlier conditions. And we use an if else if we didn't pass the first condition. Let's just do it. So our number wasn't divisible by 3, and we want to check if it's divisible by 2. But if it was divisible by 3, we don't want to check if it's divisible by 2. So that would call for an if, else, if. And if it doesn't satisfy either, we always want to handle it in the else. That's generally the approach. It's gonna depend on what problem you're trying to solve.
And the else never has a conditional because it's the last left.
Yeah, so there's no condition here because I always want to run this. But pretend that I only cared if numbers are divisible by 3 and 2. And if they're not, I don't want to do anything, then we don't need the else. The else is a generic catch-all. Else if means if I didn't pass anything above and I pass this, run this. Cool? Yes.
The number 6, it's gonna stop the first one. Cause it's like divisible by 2 and 3.
Yeah, so yes. So that's why we did it like this. So last thing, I want to write code on multiple lines. I can hold command and click. So we see here that 6 mod 3 is 0, so we logged out 3. So we don't hit the else because we already hit one if.
And if you just did 2 ifs, it would log out both.
Yep, so if they're completely separate down here, these have nothing to do with each other now. So they're evaluated completely separately. Yes.
When they do have something to do with each other, like when you have the else if,
Yeah.
when you have multiple else ifs and then still have an else.
Sure. We can repeat this pattern as many times as we want.
But else is only once, right?
Else is only once. Yeah. After we have an else here, it should probably be a syntax error if I do this. And it is. Because it doesn't know how to interpret that. So yeah, these are all the same condition. This functionally is not going to do anything, but the syntax is valid.
Quick question. So like if they're unrelated, so say you have 3 if statements, right, for this number. How do you return a value after the first if and keep the second if running?
Return a value. What does that mean?
Say the number is 10, right? So
Yeah.
you first want to check if the number 10 is divisible by 2,
Okay.
which it is.
Okay.
It will become like that's a Boolean value. So if you want to keep that, if you want to return that value to be used later, so can you?
So then I'd have to store it in something. Yeah, I got to store it in a variable then.
Oh,
And semantically, you're tripping me up because you're using the word return, so a return will only happen in a function, right? And if we hit a return statement, no matter if there's 100 lines of code below, the function is done right there. So if you're wanting to do some additional work, you got to store it somehow, and that's up to you to decide. Maybe we're going to add it to an array of all the numbers the thing was divisible by. I don't know. That comes down to your problem. All right, 5-minute break, then workshop, and solutions will be open. Give Sudoku project a shot this weekend and send it to us.
I have a question before you do the pairs.
Yeah, one sec. I'm just trying to stop the recording. Where is it?